The universe contains structures on a scale so massive they defy human comprehension. Among all the objects discovered by astronomy, supermassive black holes represent the absolute limits of concentrated mass. Today, the scientific community recognizes two primary titans as the undisputed champions of this category. On one hand, TON-618, an extremely distant quasar with a measured mass of 66 billion solar masses. On the other hand, Phoenix A, the central black hole of the Phoenix cluster, whose estimated mass reaches a mind-boggling 100 billion times the mass of our Sun. So the question is, what would happen if the universe brought these two giants together in a head-on collision and merger? Let's put these scales into perspective. For an object with the mass of TON-618, the diameter is roughly 2,600 astronomical units. One astronomical unit is the average distance between Earth and the Sun, about 150 million kilometers. If you place TON-618 at the center of our solar system, it wouldn't just instantly devour the Sun and every single planet. Its physical boundary would extend hundreds of times beyond the orbit of Pluto, stretching deep into interstellar space. As for Phoenix A, with its 100 billion solar masses, the diameter of its event horizon would approach 4,000 astronomical units. We are talking about an object sitting right at the maximum theoretical limit that physics allows for a black hole in our universe. A merger event between these two behemoths couldn't happen overnight. It requires a preliminary process spanning billions of years. First, their host galaxies would collide. When two massive galaxies enter a collision course, their central black holes don't crash into each other right away. Initially, they sink toward the new common center of mass through a physical phenomenon known as dynamic friction. During this phase, the black holes transfer their orbital energy to the surrounding stars and gas. By gravitationally interacting with billions of stars, they lose momentum and gradually sink toward the shared galactic core. However, as the distance between them shrinks, the approach runs into a physical barrier known in astrophysics as the final parsec problem. When the two supermassive black holes reach this critical distance, their immense gravity has already ejected almost all the stars and most of the gas from the galactic center due to gravitational slingshots. With no surrounding matter left to interact with, the inward journey stalls. Scientifically speaking, without an additional mechanism, the two black holes would remain trapped in a virtually endless mutual orbit, never actually merging. But let's assume an external force drives them to keep closing the gap. Once past this boundary, we enter the final approach phase, where environmental conditions become extreme. Black holes of this scale are far from isolated. They are encircled by gargantuan accretion disks of gas and dust spinning at near light speeds. As the event horizons draw close, these accretion disks collide and churn together. Frictional heating and cosmic scale tidal forces superheat the gas to hundreds of millions of kelvins through immense bursts of energy. The sheer brilliance generated by the collision of TON-618 and Phoenix A's accretion disks would outshine the combined luminosity of trillions of ordinary galaxies. This event would create a temporary quasar with an energy output that would eclipse any other observable light source in the universe. If this happened within our local supercluster, it would drastically alter the radiation we perceive and obliterate entire star systems thousands of light years away due to intense X-ray emissions. Simultaneously, the violent twisting and magnetic field compression between both disks would shoot out powerful relativistic plasma jets at nearly the speed of light. The climax of the process occurs when the event horizons finally overlap. In this phase of physical coalescence, the warping of space-time geometry reaches a critical breaking point. As two masses of 66 billion and 100 billion suns merge, space-time twists and ripples to an absolute extreme. We have never witnessed anything remotely close to what would unfold. During the final seconds of the collision, a massive portion of the combined mass is converted directly and instantaneously into pure energy. In a merger of this scale, roughly 5% of the total mass is transformed into gravitational radiation. That is equivalent to the instantaneous disappearance of over 8 billion suns, converted entirely into gravitational waves in a matter of minutes. For a few seconds, the peak power output of this emission would exceed the light output of all the stars in the observable universe combined. Yes, all of them at once. These gravitational waves are ripples that stretch and squeeze the fabric of space-time as they race outward at the speed of light. While their amplitude would be microscopic by the time they reached Earth, near the event itself, the spatial distortion would be so severe it would warp the physical distances between matter and deform atomic structures nearby. Once the merger completes and passes through the dampening phase, known in astrophysics as the ring down, a new unified supermassive black hole is born. This single object would boast a mass of roughly 158 billion solar masses. A body of this scale directly challenges theoretical limits on black hole growth. Current models suggest a natural limit cap preventing individual black holes from exceeding 50 billion solar masses. However, a direct collision like this proves that mergers are a viable cosmic loophole to bypass that limit, birthing stable hybrid monstrosities of horrifying proportions. The final fate of this new titan involves one last crucial physical phenomenon: gravitational recoil. Because the two original black holes had unequal masses and different spin rates, the gravitational waves weren't emitted symmetrically in all directions. This asymmetric emission delivers a gravitational recoil kick to the resulting black hole, much like the kickback of a firearm firing a projectile. For an object exceeding 150 billion solar masses, this gravitational push could impart a recoil velocity of thousands of kilometers per second. As a result, this colossus would be catapulted out of its galaxy, drifting indefinitely through the intergalactic void and destroying anything unfortunate enough to cross its path. Let's hope we never have to witness such a terrifying event. Thank you for watching until the end. If you enjoyed the video, don't forget to like, subscribe, and leave a comment below with your thoughts on these black hole titans.